is the beginning of Riemann sums. All right. We're going to talk about right side endpoints. What the heck does that mean? So generally speaking, we're going to find the area under the curve or between the curve and the x-axis. In other words, we want this area here. Stopping it here, beginning here. So we don't want the left side. We just want the right side and only up to this value of 2, where x equals 2. All right. Now, what we're going to do is approximate it by using rectangles, because rectangles are very easy to find the area of. All right, but this so this has 5 subintervals. Okay, so 0 to 2 is the main interval. Right, going from 0 to 2, that's the main interval. The subintervals are here: 1, 2, 3, 4, 5. So we've broken it up to 5 subintervals. Now, what is the width of each interval? You just take the size of the interval, divide by 5, and you get 0.4. Okay, usually we don't bother with decimals, but it's much easier with decimals. So that means that first one is 0.4 units, then 0.8, then 1.2, then 1.6, and then 1.6 plus 0.4 is 2. All right. Now, when it says right side endpoints, we're talking about each of these subintervals. We want the right side of that. Okay, and what we're doing is we're going to go up to the function, stop at the function, and that's going to be the height of the rectangle we're using. Each of these rectangles have a uniform width of 0.4, but the height is going to be determined by the right endpoint substituted into the function. So we're going to substitute into the function these right endpoints. So that means I want to know what is f of 0.4 and f of 0.8, etc. Okay, and our function is negative x squared plus 5. So when we plug it in, and yes, I'm going to be using a calculator. So what is the area of this rectangle? It's going to be 0.4 times, plug in 0.4 into negative x squared plus 5. So I'm going to do that on the calculator. All right, so the best use of the calculator is negative x squared plus 5. So I put it like that. All right, and I'm going to go to table set. So second table set. And my starting point is at, let's go ahead and put 0, even though we're not using 0, because we're eventually going to use 0. I'm going to start at 0. Okay, but my change in the table is going to be 0.4. Okay, it's going to be 0.4. Now, we're going to go to the table. So second table, and that gives it to me. All right. So when I plug in 0.4, I'm getting 4.84. So it's 4.84. So that's the first rectangle. 0.4 times 4.84. So that's this rectangle right here. The second rectangle will be 0.4 times whatever 0.8 plugged in is. Plug in 0.8, and I get 4.36, right? 0.8 corresponds to 4.36. So it's 0.8 times 4.36. And this is not enough space. Whoop, it's not 0.8, it's 0.4, sorry. That's the 0.8 is the number I'm plugging in, but the width of the rectangle is only 0.4. So this is number 1, this is number 2, this is 1, this is 2. Let's do number 3. Number 3 is this one. The width is 0.4. And the height is when I plug in 1.2. When I plug in 1.2, I get 3.56. 3.56. And number 4, that's number 4. The width is 0.4 again, times, plug in the 1.6, plug in 1.6, and I get 2.44. 2.44. And the last one, box number 5, or rectangle number 5, again 0.4 times, plug in the 2, and I get 1. Okay, now what we're going to do is add all these up, add all them up, and then that would be the area, or an approximation of the area. Notice this is not covering every space of that curve, so it is an underestimation, right? Because all these rectangles are below the curve, This is an underestimation. Now, because we're adding all these up, and they all have a common factor of 0.4, so the easiest way to do it is just add all these up, not include the 0.4s, but once we have the sum of these y values, multiply by 0.4, and we have the approximate area. So I'm going to do that now. So I'm going to add up. Okay, let's see, that's 4.84. So I'm adding 4.84 plus 4.36, 4.36, can't see that, plus 3.56, plus 2.44, plus 1. Enter. And we got 16.2. So that's a sum of all those y values. I want to double check. All right, I'm placing in there. So I want to double check. Okay. So I got 4.84, 4.36, 3.56, 2.44, and 1. All right, okay. 16.2. We multiply that by 0.4, and that's the approximate area, 6.48. So that's the area of all those rectangles added together. Now, let's do the left endpoint. So similar idea. Well, so we have the 0.4, 0.8, 1.2, 1.6, and 2. This time we're doing left endpoint. So we're going to start here, go up, and then go to the right. So up and down, up and down, up and down, up and down. All right, so you will notice this is an over approximation because these rectangles are bigger than the curve. All right, now the difference is, well, let's write it down first. So it's still 0.4, and let's number these rectangles like we did last time. So this is rectangle 1. That's going to be times, and then remember, my table started at 0, so there it is, it's 5. So when I plug in 0, I get 5. That's the height of the first rectangle. And then rectangle 2 is 0.4 times, I'm plugging in the 0.4. So that's the same one. 0.4 is 4.84. 4.84. And then the rectangle 3 is the next one. That's 3.56. So really, it is not 3.56. May as well. 0.8 is 4.36. 4.36. And rectangle 4 is plugging in 1.2. And that's 3. That one's 3.56. All right. That's a 4. 3.56. So really just scooted over 1. So box number 5 is 0.4 times 2.44. Right? So there we are. Notice the difference. What's the difference between the numbers? If I can just zoom out a little bit. All right, so you can see. So there's the 5. There's no 5 over here. There's a 1 over here, but there's no 1 to the right. Right? There's a 5 on this area, but there's no 5 on this area. There's a 1 in this area, but there's no 1 in this area, the second area. But all the other numbers are there. 4.84, 4.84, 4.36, 4.36, 3.56, 3.56, 2.44, 2.44. So only difference are these two, the 1 and the 5. So in other words, this one is 4 units bigger. Right? So I'm just going to add 4 to that total I had over here. And if I can remember, that total was 16.2. So I'm just going to add 4 to that. Plus 4. And multiply that by 0.4. And it's 8.08. So this area is 8.08. All right, so you might be wondering, so how did I get 4? Right. These two values, the 1 here and the 5 over here, are the only one that's different. So this one is bigger by 4 units, right? 5 minus 1 is 4. So that means the sum is only 4 units bigger. So that's it. So That is the left endpoint approximation for the area under the curve. All right, now here's a question. What if I were to repeat this and I use more rectangles, right? If I use more rectangles, these numbers will come closer and closer together, okay? And if I did let the rectangles approach infinity, all these gaps are going to get smaller and smaller. And in fact, when I let it go to infinity, it disappears. So that's how you find the area between the curve and the x-axis. And that's it.